is saying here is you can spend all the money you want. You can write Patty big checks and have her do multiple analyses, but if you're giving her bad samples, it doesn't matter. Her results are not going to be good. And so you have to have a good sampling plan, and that's really what you're talking about. What's the sampling plan, and what are we trying to prove here or demonstrate? What SW846 says, and I think if you think about the bags of candy, we need at least 2 samples, an absolute minimum, to have any estimate of precision. If you're in a facility, you say, you know your materials, you know the contaminants, so you think you know what the waste is. You sample once, it confirms your hypothesis. You sample twice, and it confirms your hypothesis. I'd say that I would personally accept that and find that enough. The SW846 assumes an 80% confidence interval, and normally says you normally need 4 samples for any estimate of accuracy. So let's run through it. This is sort of your question. We're talking about a pile in this case that's of used blast meat. It's been reused and is well mixed, but it might have been used in the past to remove paint. We don't know. We get all sorts of parts in and old and stuff, so it could have had lead pigment in it. Is it hazardous? Can we use testing or knowledge of process for this waste pile? It might contain lead. Just by the fact you say might, I think you don't have knowledge, unless you decide it does contain lead. Even though you don't know, you decide to manage this hazardous waste. So, but how many samples are enough? 4? I don't know. So what we're going to do is look at, describing exactly what you described in your question, and we're going to use TTLC as our threshold, total toxicity leaching characteristic, which happens to be 1,000 milligrams per kilogram for lead. And we took 4 samples to start. Sample A came back at 1,000, right on the regulatory threshold, right on it. Sample B is above the regulatory threshold. Sample C is below. Sample D is again above, but not so far above. So, sample A contains 100 milligrams per kilogram. Is the sample A, not the waste, but is sample A hazardous waste? Yes outweighs no. Let's see what the law says. So the question was, the sample A is the sample, not the waste. If you said the waste and said no, or I don't know is what you're thinking, then that would have been a good answer too. But the actual sample itself we tested, and it was right on the threshold, and the threshold is equal to or greater than. No big deal if you didn't quite understand that. I'm just warming you up here. Now we're going to take these samples and look at these questions. Based on these 4 samples, can we determine that the waste pile itself is a hazardous waste? Is the answer yes? 3 out of 4 samples are equal to or exceed the threshold, so that's good enough. No, it's 100% or nothing. Or the other one is I don't know. More analysis maybe more samples are required. I'm counting the respondents. Still have 43 people participating. Let's examine the answers. So I think there's more samples, but now you need to guess how many is enough. So you've got 1 through 4. Based on your knowledge of those samples. Not bad. The actual answer is you need 15.31 samples. And we'll go there. We're going to show you how to do that. And there's one little trick. To be honest, when I first did this presentation, I just kind of picked the numbers without any thought. And when I did, I said, oh, I just learned something by the numbers I picked. And you, for those of you, some of you in here will too. And so where'd that number come from? It's a 7-step. This is the Statistics 101. You determine the mean, which of course is the average, then determine the variance, the standard deviation. And I do it the old-fashioned way. You know, we could do it with pencils and paper. Although I don't know how to do a square root anymore. I'd use a calculator for that. Determine the standard error. I used to know how. Maybe one day when I retire, I'll figure it out again. Determine the confidence interval, and then determine if the variance exceeds the mean. And then you determine the appropriate number of samples. Am I losing people? What?
No, just skip it. It's not a question.
Oh.
Sorry.
Okay. Yeah, the point here, you know, and I found that probably less than half of us are enamored with math. But if give it a chance, really, it's just really addition, multiplication, some division, and yeah, I mentioned the square roots. And if you really hate numbers, just pretend to listen. And remember, you need at least 4 samples, and more samples may be required if the waste is heterogeneous or close to the regulatory threshold. That's where it gets tricky. So the mean, it's just the average. So that's, whoa. So yeah, you just, you add up the 4 numbers and divide by 4, and that's the average. The variance is a little bit different. It's estimating the area from the mean to the end of the population curve. And mathematically is the easiest way to do it. It's and I'll show you the formula rather than describe it mathematically, because most people can understand that more easily. Now, the standard deviation is simply the square root of the variance. Oh, how many people have heard of Six Sigma management theory? What's Six Sigma? Does anybody know? It's a 99% confidence interval. It's 6 standard deviations. Sigma is the mathematical symbol used for standard deviation. So I'm pretty sure Six Sigma captures a 99% confidence interval. And that's the idea for it. It's approaching perfection with the Six Sigma system. So SW846, remember we had a confidence interval of 80%. So that means there's going to be 10% on either side that we could miss. But if you take 100 samples, 80 should be within the confidence interval. 80% should be representative of the actual population. Now, normally you would evaluate all 4 samples. What I'm going to do is, in the numbers that follow, I'm going to run through all of these 7 steps with 4 numbers. And I'll try to do it quickly as more and more people fall asleep. And then I'm going to go through with the 2 to show you what happens with different numbers and different frequencies. But you need to obviously consider all 4 for correct analysis. So, we've got the 4 samples. The mean concentration of 4 is 1012.5 parts per million. Now, notice on the lower numbers down there, I'm talking about if I just use sample A and B, if I only took 2 samples, those would be the difference results, C and D and so on. So if I just took 2 samples of the same waste pile and combined them, these would be the results and what it's telling me. So the more you take, the more precision you get. Now, the variance, you just take, sample A minus the mean squared plus sample B minus the mean squared and so on, and divide it by the number of samples minus 1. And in that case, You know, the variance for this is 891. Pretty big variance, really, when you're talking, you know. And then if you look for, like, the fewer samples, you can see A and C, which were actually very close, the two samples in value, the variance is much less, whereas it increases much more where A and B were the two samples that were the furthest apart in their values. Pretty common sense, intuitive stuff, but just plugging the numbers in to show you how it works. And of course, the standard deviation is simply the square root of the variance, so there's not a lot of interest there, but it's like 30 is a standard deviation, which isn't too bad. But that's saying that, you know, we're going to be that number around 10, 12 is going to be plus or minus 30 is what you can expect based on these. And the standard error is simply the standard deviation by the square root of the number of samples. In this case, it's 14.93. We're using this to get to the confidence interval. Confidence interval is the mean plus or minus the student t. Student t, I remember when I had statistics, oh, I can tell you the truth, it's about 40 years ago. You know, and student t was a table in the back of the book. You know, and you just go flip back to the pages and pick it. It's also in Chapter 9 of SW 846. And the more samples you take, the lower the student t gets. So, and that also affects it because the confidence interval is the mean plus or minus the student t times the standard or the standard error. So, you know, the tighter you get, the lower the number. Now, this is, remember when I talked about, this is one step that confuses a lot of people. If the variance is greater than the mean, then you've got to do a transformative value, which is just basically chugging and plugging through the numbers. But what we're talking about is if the actual population goes into the negative. You can't have a negative amount of candy. You can't have a negative amount of lead in a contaminant. So you have to shift that population into the positive. It's and so you can either do that by using logarithmic functions or just squaring the numbers. I'm not going to. The first time I did this, I tried to do this with all of them, and I really lost everybody in the class. So I'm just doing it one time. It's really very simple. It's just, you know, you just do the exact same process, but take the, you know, square the number and take the square root. But one example, you know, would be with the transforming the mean. It's nothing particularly difficult, but it's a whole other set of steps. Oops. And then that's what we talk about. It's just routine plugging and chugging. But you need to understand that what we're doing is saying the population cannot be negative, and we need to shift it into the positive area. Regulatory threshold is involved in the number of samples. So now we're using the number of samples as the student t squared times the variance divided by the regulatory threshold minus the mean squared. Just numbers, you know. And I forget who came up with these, but it was after a lot of work. Oh, we're fixed, huh? But now, if we just use samples A and B, you know, we only took 2, that would tell us that we need to take another 8 samples. If we use C and D, it's telling us we have to take an infinite number of samples. You see what happens there? What happens is C plus D is 1,000, and you divide it by the regulatory threshold, it's 1,000, and so it says you got to sample the entire population. So that's why when your sample values are close to the regulatory threshold, you've got to take a lot of samples. Now, B plus D, which is only said 4, well, let's say 5 more samples, and then if A plus C would say you'd have to take 19 more. That's just, you know, your first 2 samples, you can get that and then go ahead. So the more samples you take, the more you learn. But I think you would want to just, typical thing is to start out with 4 and see what you got it, and generally that's good enough. It's not in this case because we're close to the regulatory threshold. It's not working. So so when we do this, we come up with 15.31. The samples are very precise, and they're unbiased, but the problem is they're very close to the regulatory threshold. So this is a key. Fewer samples are so required for homogeneous waste, or if it's well above or well below the regulatory threshold. Makes sense. That's a takeaway. Yeah, you can look up the numbers and just plug them in. It's really pretty simple. I'm sure there's good software to do it too. Now I'm going to talk real briefly about other types of sampling: stratified random sampling, systematic random, and authoritative sampling. You see this all the time. They're doing it every day. Okay. What age and gender groups like Newt versus Mick, whatever his name is, socioeconomic status, religion, nationality. When they're doing the political polling, they like to divide people up into strata, to determine, what that particular group is going to do. How should I focus on them? And so that would be. To do that, they take individual. They do simple random sampling of the individual strata. Now, when might we want to do that? For episodic generation. Now, I'll use that blast media. You use different types of processes. You change the processes, batches, so you could do it by month. You could also do it, visualize this thing as a waste pile that you were discussing, where that was generated over a period of time. You might take it strata that way. But you see, it's really pretty simple concept. You just apply simple random sampling to different strata, which is, and it's very common in the political world. Systematic. It's nice, when you've got a random numbers difficult to apply when it's counting every instrument. In this case, for those 4 of us that are going to the CUPA Cup tonight, or 8 or however many, and we decide for next year how much food we want, as you enter the door, or exit the door, I guess. We didn't like that. It might be better. So we start off with a random number. And we know that there's 40 teams in there, and the sample sizes we think 4 is good enough, and so that means we want an interval of 10. So we sample a random number between 1 and 10 is 7. So the 17th out the door, you ask them what they liked and didn't like, and then ask every team, the 17th team, the 27th team, and so on. That's systematic random sampling. You see these, the most common use, I think, in our business is, like you got a long pipeline and you're testing it. You start with one random and then you test every 20 feet, I think, is a typical standard. I bet there's some people in this room that have done that and know more about it than I do, but that's commonly what I see for this type of sampling. That's systematic random sampling. Really the same thing, it's just how you start and proceed. Okay, when does the inspector inspect? We're required to have a graduated enforcement policy from informal to formal inspection. You observe evidence of a Class 1 hazardous waste violation, but you got to collect evidence that proves all elements of that violation. What's the first element? What's the most important one of a hazardous waste violation? Is it a hazardous waste? And that's what you sample for. And that's what we're going to prove, that this exceeds the threshold. We're looking for an exceedance as an inspector. Okay, so does the inspector have to take representative samples? And I left the answer underneath, but you don't have time to read it. You just have to, unless you're really good. Correct, I think. Let's go back and read the answer. So No, inspector does not have to take representative sample because you got a different data quality objective. You're looking for an exceedance. And so that's our data quality objective. Whereas, and if you're on a witness stand, say it's an authoritative sample, not a bias sample, authoritative. You could argue that they're one and the same, but really inspectors are experts. That's what you do for a living. You go out and identify hazardous waste, and your data quality objective is determining exceedance. Just you're trying to find a sample that is hazardous waste, and you've got experience, you've got training, you understand this, and that's called also can be called judgment sampling to validate your expertise. Use knowledge and experience, but you should, document what you're doing and why your thought process and why you did that, and then say right up there. So, okay, enough on sampling.
Any questions?
Want more on sampling? Okay, waste determination. The regulation is process knowledge or analysis. So what constitutes process analysis? And now I'm going back to the Office of Solid Waste and Emergency Response Guidance document. And we call it acceptable knowledge. And to me, the obvious one is you know what comes in, you understand what the contaminants could be, and therefore you can figure out what comes out. You can get waste data from other facilities. You can get waste data online from the manufacturer. There's a lot of sources of other knowledge. You can use old analytical. Well, 2 years ago I did this, and then, nothing changed. A lot of information is acceptable as knowledge of process. And then the US EPA in this guidance document talks a lot about it, but it says you need to have detailed information. You want to document how you arrived at that conclusion. And now we go into when US EPA. And US EPA, for those of you, the regulated facilities in here, the deck is stacked against you. You'll see this. US EPA not going to come out and really even clearly say that knowledge of process is ever acceptable unless it's clearly non-hazardous or it's clearly hazardous. And things like, if it's a listed waste, by definition it's a hazardous waste. Obviously, knowledge of process is how you make that determination. P&U listing, if it's a discarded chemical, it's too dangerous to sample. So you can use knowledge of process. It's just not practical to use knowledge of process, but they're going to point you towards managing as hazardous waste. The lab can't determine whether it's hazardous. There's some things like reactivity, and if you delve down into it, there's not a good test for that. We've got a ignitable solid test in California, and I'm quite frankly, I'm reluctant to use that because it's just one of my favorites as an inspector. We took one and rags contaminated with MEK. We think it's hazardous waste. Let's see if it's ignitable. And so we did the ignitable solids test, but we went ahead and did a uncontaminated wipe or rag, or I don't remember what it was as a control, and the contaminated one failed for ignitability, but the uncontaminated one burned even faster. I said, we can't use that. I don't feel comfortable doing that. But probably on the generator side, you might consider it prudent to manage them as hazardous waste. US EPA is generous here. They say the regulations will allow you to manage anything you want as a hazardous waste if you don't think it's economical to sample. And they go so far, and there's a book, there's a class called McCoy's RCRA Unraveled, which a lot of us are very fond of, and their books are wonderful if you're really in the business. But they say nobody's estimated what the cost would be. I think to do all the tests, it would be close to $6,000 or $10,000 per sample if you ran all the tests. And so you talk about 15 samples, and then, it can get non-economical pretty quickly. Questions? Yes.
Hold on one second.
She's going to have a good one. Oops.
Again, just based on some experience I've had in the past where, like at a remediation site and working with DTSC, they are very concerned that the sampling be, the random, when you put it into a model and you make sure that there's absolutely no bias to it. And so we just do the grids, and this is completely random. They wouldn't allow us to do any professional judgment on the sampling. And they said that was because when they were in court, if it does get litigated, that was the only way that could really, be considered fair. So it wasn't so much that the agency or the person enforcing it had a duty to go out there and try to prove it exceeded. It was more that they had to go out there and really get a representative sample. That just seems contradictory to what you said earlier, that it's the regulator's responsibility to demonstrate that there's a hit.
I don't think I understand the question. I don't.
I guess you said that should the inspector, does he need to take a representative sample or not? And it was not, because it was his duty to try to demonstrate that there was an exceedance. It
Right.
just seems to me that it should be the inspector's responsibility to make sure he has a representative sample.
Okay. That's a very good comment. The comment was that the inspectors really should have as much, I think, let me know if I paraphrase this correctly, the same response, be held to the same standard as a regulated facility is that they want to get accurate representative samples and determine what the waste is.
Yes, I mean, I guess the long part of my comment was the fact that in litigations I've been involved in, that was the judgment of the court, was that you needed a representative sample. Whether you be the enforcer or the,
No, and I think if I understood correctly, what you just said is that if you took it to a court and argued that in front of a judge or jury, I know of no case law on this particular subject. A DA recently forwarded something to me, but I don't think it was a case law. But you could, you might win that argument in court if you want to go to that expense and fight that. Sandy, that's not really an answer, but the more data you have to support your position, the better off you are. I think if the facility does a really good sampling plan analysis and does all that, they're probably in pretty good shape.
Maybe we're talking apples and oranges a little bit here, maybe. Are you referring to maybe a cleanup site versus an enforcement action? Because cleanup may be a little different. We're having an agency coming out and asking for a cleanup standard versus an enforcement action. So I think we might be looking at things a little differently.
A question over here, I think, Sandy.
Okay, hold on.
They want you on the microphone they don't like, my paraphrasing is failing the test.
No, I just wanted to make a comment that when you're out to do an enforcement action, you only have to be right once out of those 15 samples. But the generator could have all sorts of data that shows that he averages and he meets the EPA averaging method. And then what ends up happening is because you had one sample that spiked, you're in an enforcement action, you're in some kind of a consent decree, and although you could go to court and pay those expenses, it's really skewed against the generator if he's done his homework if you find one sample that's bad. Because the enforcement agent is going to say, okay, that one drum was hazardous waste, or that one spot was hazardous waste. And it just seems like you're not playing fair.
I would not enter into that debate with you if I was going to debate about, clearly the hazardous waste laws were written to catch bad guys. And you've got to do manifest, you got to label, everything's got to be closed. The standards that a hazardous waste generator are held to are very high. And it's not just in the waste determined area, it's across the board if you're doing it right. But I would argue, if you had a good waste analysis plan and documented your thought process and how you did there and took an appropriate amount of samples, that we would be so impressed with that facility, we wouldn't even think about enforcement action. We would want to put you up as a model. And that's the truth. I mean, Sandy, how many places have you think of before we went in and inspected multiple times and wrote multiple violations that they had a good waste analysis plan and did good sampling?
Right, and the key is that it's the generator's determination. So if a regulator comes up with one sample and the generator has an excellent waste analysis plan to dispute that one sample as an anomaly, the generator's in charge. The generator makes that determination. And so we would have the burden of proof that that sample, that one anomaly that we took is representative of your entire waste stream. I think we would be, that would be hard to prove.
And I can give you an example, and now I'm only really talking about me in San Diego, but we once did an enforcement case, they were powder coating waste in the trash. The MSDS said it contained zinc. We took samples, gave them a split. Our sample came back zinc. And so they didn't do anything or contact till when they came in for enforcement meeting, they had a consultant, a good, knowledgeable consultant. They had a lawyer with them. And their sample came back non-hazardous. And I looked at our county counsel was there and looked at him and said, okay, we don't have a case. In other words, we could have argued that we still had a case. We had the MSDS and the sample. We said, no, we're not going to argue. But we did ask, can we have that sample and test it again? Your sample, your split, let's say you were the and they said, sure. And we tested it and it was non-hazardous. So I don't know. Obviously it was non-homogeneous, but in that case I decided, I was not comfortable, nor was our going forward with enforcement action. I don't want to. Why? If the facility manages that waste properly, that was our goal, and that's where we were going with. And so it took them a long time to get there, but it wasn't a rock-solid case, so I didn't want to pursue it. But and I think you'll find that most of us in the unified program world think along those lines. I think. I'd like to think so.
So on the statistics, could you not apply a upper control limit and a lower control limit to verify or validate that the samples that you've taken are indeed above or below the threshold? It's used in quality control, so you establish a band with the upper limit and a lower limit, and if the upper limit is still below your threshold, then you're below the threshold.
In the time that I see that most often is aquatic toxicity when we go there. But typically, I was just walking you right through Chapter 9 of SW 846 and the methodology they spread. Of course, we do talk about, field blanks, lab blanks. And Sandy, in the next part of this presentation, is going to talk more about the quality control in the lab. But we do periodically take field blanks and that sort of thing for quality assurance. But setting the lower controls is not typically done. In aquatic toxicity, we've done that before, but I've found that when I do that, I end up killing a lot of fish and spend a lot of money, and it's the best just to go for the definitive first. Anybody else?
Yeah, I just have one comment. I've been doing this for a while, and it seems to me that it's the generator is held to the standard of having to prove the negative, whereas the regulators are they're basically assumed to be the expert. They simply have to find that one sample that exceeds that threshold. So a lot of times I find myself in the situation of, just like you said in your manual here, it's cheaper. You may be right, but it's going to be cheaper to just go ahead and manage it as hazardous waste because you know that it's going to be extremely expensive and or a legal nightmare to prove that negative. So I just wanted to make that comment.
Again, I used available guidance documents and the methods, and I think they kind of support your comment. The one thing I do see for a lot of businesses that we go into, they let stuff accumulate. Let's over a long time before they clean it up, and so the contaminants, typically, particularly with aqueous types of waste, so like in a trench or something, the sludge tends a bit up. If you cleaned it more frequently, which is probably a good practice, it's less likely to exceed the threshold. You see where I'm going there. That's the only comment I could have that would even support, or not support, that would have that might weaken your case a little bit. But quite frankly, I think you're right. That's the way I describe the system.